All right, so moving ahead with linear functions. All right, we talked about, the first lesson, right? Defining functions. That's pretty much what we did. The second lesson in this chapter was taking that function and realizing that it's part of graphing. You can graph to represent the function. Okay. Now, today's what we're going to do is we're going to take a look at tables and graphs, and we're going to describe the function in other ways. All right. And in that way, what we're talking about today is we're going to be talking about two things that are closely related. We're going to be talking about something called the constant rate of change, and we're going to talk about something called the slope. All right. So here is, we have some vocab. So we all have green on the left, notes on the right. Here we go. Here's our very first phrase or word. It's rate of change. Everyone?
Rate of change.
So here's what rate of change is. It's a change in one quantity with respect to another quantity. A change in one quantity with respect to another quantity. Okay? So this will make more sense, of course, when we actually do our problems and look at them. So you're going to see these on tables and graphs. All right. A lot of times, though, it will be often related to real life situations. Okay. Our next phrase or next word here is linear relationship. Everyone?
Linear relationship.
This is a relationship that has straight line graphs. Straight line graphs. So what that means is that you're going to see some information in a table or even a graph, and you'll be able to look at either one, and that's kind of what we're doing today, and we're going to describe whether or not it has what's called a linear relationship, meaning obviously it creates a graph that causes a straight line, right, which we've been talking about a lot lately. All right, the next one, we've talked about rate of change. Now this is something a little more down your alley when it comes to our homework. It is the constant rate of change. Everyone?
Constant rate of change.
So it says the rate of change between any two data points in a linear relationship is the same or constant. So when a rate of change is a linear relationship, you can say that it has a constant rate of change. So this actually is described as a unit rate. We talked about rates and proportions and things earlier in the year, and you're going to see it's going to kind of come back around. It's expressed as a unit rate most of the time. And our next one, the word slope. Everyone?
Slope.
And this says this is the ratio of the rise or vertical change to the run or horizontal change. We're talking about the graphed line now. And here's the best part, and basically the best way to describe it. It says the slope describes the steepness of the line. How steep the line is. Is it steep? Is it not? But it's a number that describes how steep it actually is. So, I'm going to don't copy that down, write this down. What we usually have is we have the first y coordinate, that's a little one subscript, minus the second y coordinate over, it's like the numerator part, over the first x coordinate, so x the little subscript 1, the first x coordinate, minus the second x coordinate. Okay, where you know? Guys, when you find out the difference of the y's, that will actually describe the rise, which of course, remember, is the vertical change. When you find the x, the differences of the x, that is the run. or the horizontal change in the line. All right, and we will come back to that during our lesson. All right. So, with that said, let's go ahead, if we haven't done so already, grab our books. Okay, so let's go ahead, let's start. We have like 4 different types of problems we're going to take a look at. So let's take a look at the first one on page 399, and let's take a look at problem number 2. All right, problem number 2. It's a table. All right, and in this table, you have the relationship between 2 different factors here. It's the time in minutes and the altitude in feet. So they say at 4 minutes, the altitude is 160 feet. In 6 minutes, the altitude is 120 feet. In 8 minutes, the altitude is 80 feet. And in 10 minutes, the altitude is 40 feet. So, here's the thing. The directions say find the constant rate of change between the quantities in each table. Okay? There's a rate of change, but they're not asking if it's constant. They're saying there is a constant rate of change. So here's what you need to realize. Okay? Step 1 is go to one of your quantities and find out what is it changing as the chart goes across. So 160 going to 120. It's a decrease of 40. In this case, a decrease of 40 feet. I take a look here. 120 to 80 is a decrease in 40. And 80 to 40 is a decrease in 40. Step 2 is take a look at what's happening in the time. In this case, there's an increase in 2 minutes. And because it's a constant rate of change, there's an increase in 2 minutes each time. Now comes step 3. I'm going to go ahead and I am going to place this factor here because I'm looking. I say, okay, well, it's usually feet per minute. All right, when you're talking about a rate or a unit rate. So I'm going to go ahead, I'm going to extend my feet on top. This is a change of negative 40 over an increase in 2 minutes. Step 4 is simplify. Well, I divide both by 2, right? That's what it means to simplify in this case. It's a decrease of 20 over 1. Okay? And okay, step 5, is put your units on there. -20, and right, this is in the 20. Remember, is the feet. The 1 is the minutes. Bless you. And step 6, and so many different steps, guys, but they're not very hard or long, time consuming. At this point, change it to a sentence or a phrase. So we can have -20 feet per minute. If you put like a drop in 20 feet and actually change that to a word, I'll take that too. That's even better. Okay. Okay, questions about rate of change. Remember we talked about constant rate of change, right? You know, right? That's kind of what we're doing here.
Question on homework. Do we have to draw the graph?
The table?
Yeah, draw the table.
No. Any other questions? All right, here's one I want you guys to try. Try out problem number 10. Number 10, go. Anyone need more time? Okay. All right, anyone still working on that one? Okay, about 30 more seconds, guys, and then we're gonna share. Okay, 30 seconds. Go ahead and turn to your neighbor and share. Go.
I got 1.66 yards of fabric per band.
I wasn't really sure but I've written this down. How to divide
All right, here we go. All right, so what we have is we have banners. Looks like maybe, I don't know, let's say leadership or something are making banners for something. I'm just making up a fake story, but that's kind of what it looks like. The number of banners, the fabric, and measured in yards. All right, so when there were 6 banners, there were 8 yards of fabric. When there are 9 banners, there are 13 yards of fabric. When there were 12 banners, 18 yards of fabric. And when there are 15 banners, there are 23 yards of fabric. All right, so here we go. Step 1, let me go ahead and find out what's happening here. So there's an increase here of 5 yards. There's an increase of 3 banners. All right. So, so what we want to do is we want to make sure when we look here, all right, we go through and say, okay, well, we probably want to know, of course, how many yards per banner, right? When you're buying material, for example. So we sit there and we say, okay, well, we have a 5, right, over positive 5 over an increase of 3. So if we're doing this here, I'm going to go ahead and if you wanted to put your units here, you could. Okay? Yards, banners. You don't have to, not until the end like I did. Okay, but if you want to try to keep track, make sure you set it up correctly. Okay, because we're dealing with a unit rate, we want it to be a 1 on the bottom. So how many yards per banner? So if I divide by 3 here, I divide by 3 there. And here's the funny thing, right, is you can go 5 divided by 3 with your calculator, or you could say 5 divided by 3, which happens to just be that fraction, and change it to a mixed number. 3 goes into 5 one time with 2 left over. So we have 1 2/3 yards per banner. Decimal wise, what would that be?
1.66.
Yeah, okay. 1.66 is right with in bar notation. Yeah, bar has to be over the top. So those of you that solved it that way, I'm okay with that. Remember, it didn't start off as a decimal or fraction, so I'll be okay with either answer. Okay. Questions? Okay, let's go ahead and let's take a look at problem number 3. Okay, find the constant rate of change. So, constant rate of change for each linear function and interpret its meaning. All right, so constant rate of change. Okay, what we have is we take a look at one point and then the other. Okay, so here's what we do. If we take a look, all right, the height of a plant is increasing from here to here. What's it increasing by?
2.
From 3 to 4? What is it?
1.
Yeah, it's 1, right? Just double checking there. So step 1 is find the change. Okay? And guys, this is what we'll call the rise. So it increases in 1. In this case, if I want to put it, 1 inch. Step 2. What does it increase with weeks? Well, it goes from 0 to what?
2.
2. It moves 1, 2 to get from this point to this point. That's called the run, by the way. Now comes step 3. What is it per week? We reduce. Well, divide by 2, what do we get? 0.5. Step 4. It does say interpret its meaning. So you'd say the plant grew 5/10 inches per week.